Hey guys, we're going to do a little bit of a deep dive on triangles and congruence. We're going to talk about Cpctc. We briefly mentioned it in the past week, but it's a pretty big deal, so we're going to go a little bit more in depth. So the first thing is we are going to decide whether enough information is given to prove that the triangles are congruent. If so, we'll write the triangle congruence statement and then the postulate that we use. So we're talking about, are we using side, 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 angle, angle, side, angle, side, angle, and side, angle, side. Those are the four that we've looked at. So if I look at number one, and probably what you need to do is just pause the video and then join me back. That's what we did in class. We let everyone take a look at it. So do that and then come back and meet me with number one. If I look at those, I know without a doubt that TV is congruent to TV. So if I'm looking at the left side, I do have side, I do have angle, I have side. But on the right side, I do not have that. I have angle side side or side side angle, no donkeys. So we do not have enough information. They could be congruent, we just don't know. Number two, if I'm looking at these two triangles, what did you come up with? Hopefully you see that we have our pair sides that they have given to us. We have the angles here. We need another side or another pair of angles, and we have MN that is congruent to MN. So if I were to write a congruence statement, I would say triangle LMN is congruent to triangle TNM. Okay. And we know that would be based off of side, angle, side, on the other side, side, angle, side. So that's the postulate that we used. The last one, if I'm looking at those two triangles, I have two pairs of sides, and then I know that I also have vertical angles right here. So I would have side, angle, side again. And my congruent statement would be triangle ACB is congruent to triangle ECD. Now, it does not matter how I named that first triangle. I just went off of what they had there, just as long as I know that my corresponding vertices match up over here. So angle A matches angle E, etc. So here's where the CPC comes into play. Once we have congruent triangles by definition, then we can say that corresponding parts of congruent triangles are congruent, or Cpctc, because corresponding parts of congruent triangles are congruent. That's quite a mouthful. So if I look at the two triangles over to the right, how are they congruent? Well, I have a side, I have an angle, and another angle. So we could say because of side, angle, angle, or we've been calling it angle, angle, side. But I also know that because those two triangles are congruent, then the corresponding parts are also congruent. So what corresponds with angle B? Well, that would be angle E. So angle B is congruent to angle E because of Cpctc. I also know that side AB would be congruent to side E. And then the last side, I know that DF and AC are congruent. So AC is congruent to DF. Okay, all of that would be because of corresponding parts to congruent triangles are congruent. If I'm going too fast, just slow it down a little bit, but we're going to do the same thing on 4, 5, and 6. State why the two triangles are congruent, then tell what other parts are congruent. So I have the three pieces here. I have a side, I have an angle and a side, corresponding angle, corresponding side. So I have side, angle, side is how they are congruent. And then what other parts are congruent? Well, I know that angle X is congruent to angle A. And I'm basically letting the other congruency marks guide me that way. So I'm going to say that angle X is congruent to angle to, it would have to be AZ because they correspond. A is the double-sided angle, X is the double-sided angle, and then that would just leave us with the other vertex there. And then we have one more piece, and that would be angle Z is congruent to angle Y. Five, if I'm looking at 5, what do I know about those two angles? Well, I know that they have given us a side, they've given us an angle. We don't know anything else. We don't know if BC is parallel to AD, therefore we don't know if these are congruent to each other. But without a shadow of a doubt, I know that BD is in both triangles, so it has to be a congruent pair for the reflexive property. So I know that those two triangles are congruent by, looks like side, angle, side. So all the other parts, this angle and this angle, so I cannot name that B and D. I have to use all 3 letters because vertex B is part of several different angles. So angle CBD would be congruent to angle, well, what corresponds with C? If you're not sure, look up here. Angle ADB. Okay, so we got that angle out of the way. We've got another angle over here. Okay, so angle C, I can call that angle C, is congruent to angle A. And then the last thing that we have is the side in between those two angles. So side CB is congruent to side, again, got to go with the order, so AD. All right. Try 6 on your own. Come back and meet me, which I'm sure you have. All right, so I know that YA is congruent to YA because it is in both triangles. If ZAY is congruent, or is 90 degrees, and so is BAY. So we would say, again, we have side, angle, side. I think we've used our allotment of side, angle, side today. All right, what else do we have? Well, I know that angle Z and B are congruent because of Cpctc. So angle B is congruent to angle Z. Okay, I know that this angle is congruent to this angle, but I cannot name it angle Y. I have to use all 3 letters. So how about ZYA is congruent to angle BYA. And then I have this last side here. So ZY congruent to BY. Okay. So again, if I know the triangles are congruent by side, angle, side, or any congruence postulate, then I know that the other 3 parts are also congruent to their corresponding part. Okay. Jason came to class late, and your teacher told you to explain to him how you know that angle D is congruent to angle H in the following triangle. So when you're looking at this, first thing is first. The first thing that you guys see when you see angle D and angle H is you're probably thinking that's alternate interior angles. Yes, but you don't know if they're congruent unless you know that DE is parallel to GH, and there's nothing that gives you that those 2 angles are congruent. So the only way that you can prove that those 2 angles are congruent is to first prove that the 2 triangles are congruent, and then you would know that angle H and angle D are congruent by Cpctc. So what you would tell him is first prove that triangle, I'm going to call it DEF, is congruent to triangle. If I use DEF, then I have to use HGF. HGF. Okay. And And to do that, I'm going to say that I know that my vertical angles are congruent. So I'm going to say angle GFH is congruent to angle EFD because vertical angles are congruent. Therefore, or thus, we'll say thus, triangle DEF is congruent to triangle HGF because of side angle side. So we are using that again. Therefore, remember that symbol means therefore? Therefore, angle D is congruent to angle H because corresponding parts of congruent triangles are congruent. Ta-da! Okay, go back and read through that again because you're going to be seeing that a couple more on the next page and in your prep work. Jerry Ann wondered if she could show that side BC and DA are congruent to each other by using Cpctc. She knows that AB is parallel to side DC and that angle B is congruent to angle D. How can she show that the triangles are congruent, thereby leading to show that side BC is congruent to side DA? Well, let's see. She's got one piece of information of angles that are congruent to each other. Okay, we got our angle. And we know that we have parallel lines. Well, parallel lines create alternate interior angles. So I'm going to use these two right here, congruent alternate interior angles. You could have used these instead, and that would have still given you the same answer. So it doesn't really matter which ones that you choose to use. Those are the ones I'm going to choose to use. And then the other piece of information that I know is that AC is congruent. Okay, so I'm going to prove triangle ACD is congruent to triangle CDA. Trying to make sure all my pieces are correct. I think I missed a B somewhere. Triangle ACD. Yeah, I surely messed that one up. ACD and CAB. That's what I need. Apologies. Much better. Okay. So to do that, I'm going to say that angle BAC is congruent to angle DCA by the alternate interior angles theorem. I'm going to say that AC is congruent to AC by the reflexive property. Okay, so my triangles are congruent to each other by angle, side. Okay, so now I have enough information to prove that BC is congruent to DA by Cpctc. Okay. So what we were planning on doing, or what we did in class, is that we kind of talked about this one really quickly because I want to give everybody a chance to work through number 9 on their own. So you can show me that one later. But you had a proof with midpoint. It's not telling us that anything is congruent. So to prove that our triangles are congruent, we're going to need to do something with the midpoint. So X is the midpoint of BD, so I know that this is congruent to this, because that's what a midpoint does. And I also know that x is the midpoint of AC, so these two are congruent to each other. And what we're trying to show is that angle XDC, so XDC, oh, that would be this one, is congruent to XBA, this one here. Okay, so I'm trying to see, so these are the triangles that I'm going to prove are congruent right here. This one and this one. So I need another angle because I cannot prove that XDC and XBA are congruent yet. But I do know that these are congruent here. So angle DXC is congruent to angle BXA because vertical angles are congruent. Okay, so triangle DXC is congruent to triangle BXA. Again, side angle side. Okay, therefore, angle XDC is congruent to angle XBA by corresponding parts of congruent triangles are congruent. Ta-da! Okay, so that wraps that up, but I want to go to the homework. You should be okay to do the best you can on the first three, but this is a little lengthy, so I cut it down. I want you to do these three here because it's asking you to do the same thing over and over again. By all means, if you want to do those, please do those. It's just extra practice. And on the last page, you're going to do 11, 13, and 15 as well. All right, so that is it. Let me know if you have any questions. Email me at my .com. That's not what I wanted to do. That's what I wanted to do.